Hello everyone. I might be giving this one a bit of a rest because, well, I went to trouble of mapping all the sensors using my Arduino down here, and I found out now that my Arduino uses 5 volts and my actual 3D scanner uses 3 volts, 3.3, because it's run off the STM32. And there's 5 sensors and I've mapped all 5, and I'll just show you how I mapped them. But what I found out is that when I go back to, I mapped them all on my Arduino down here. This is 5 volts, and basically what I did was I put each joint inside my jig onto this on my turntable for my scanner. Now my turntable, what I did is I put it in the laser and I scribed 1 degree intervals all the way around it. And so what I can do is I put a post here and then a wire on there, and I could set the 0. So what I could do is I could rotate this to 0 and then map it every 10 degrees as I went around on this thing. And I put this camera up so we can see it, save me bending down all the time. Yeah, so you can see here, see the post there, I painted that yellow and my little wire red. So that's this thing here, this wire over here. And what I can do is I can bring up the, well, I wrote an application to make it easy for me to do. Well, I write an application for everything, don't I? 1 minute, I'll bring it up. Yeah, so this is my application. I don't need to see it. Right. So yeah, so we can connect. Oh, I haven't connected it up to the to the USB. Can't connect yet. Give me a minute. Right, now I can connect. Okay, so I've got it connected, and so originally I did it. Connected it to the Arduino using I2C, and I needed that to set to program the zeros. So you lined it up to what your actual 0 was, and then you can program that in, and you can burn it into the EEPROM. So, like I say, I put a button here and burn into EEPROM. But I realise now that I could only do that once, so it's a one-time burn. So basically that's wasted. So lining up the magnets was a pain in the ass, basically. So I've changed all these out to let me just well, I'll show you the round magnets and what I've done in a minute. What I want to do is because I've got it all set up, is to show you how I map all the angles. So we could turn this around, sort of thing, like this, and basically we're doing the output. And so what I do is I set it to 0. So we're looking at this number up here, this raw value. This is the angle. It's the raw value converted to degrees. Actually, so I mean, because it's 14-bit, this is divided up to 16,383. So we set it on 0, and then look at the needle. So I've got a little wire here as a needle, and I set that to my 0. So once that's on 0, where all's on 0 now, we log that point. So I get our zero start, and then what we can do is we can go around every 10 degrees. So I line it up with the 10 degree mark and I log that value. What the hell have I done here? Give me a minute. I just updated the me application to so I could choose which input the data was coming from, and I forgot to add this value here, so I've just added there. I forgot to update in the when I process the angles, update the actual raw value. Anyways, it fixed. So let's go back. Right. So yeah. So we're looking down here. So at that point there. So that is my 0. So we check that lined up is accurate. Well, basically I get this to 0. There we go. Just touch. Oh, pressed it. Yeah, there we go, 0. So we can log that. So we've got that 0, and then I just move to the next point, which is my 10 degrees. Yeah, get it spot on, because like I say, it's quite accurate. It's, well, what did I say, 16,000 points now. So we can log that as well, so you can see that's logged, and I just keep going around. And this is what I did for all the sensors on the Arduino. Currently I'm doing it on the STM because I'm at 3 volts now, basically because the angles are different. So I logged them and I have to go around, so I re-logged this and I keep going round and log again, and if I go around again, so next one, there we go, 10, log. So I keep going down and I keep going round, so I go round and do log each one like this, get it exactly right. And then once I've done all that, if we look at my code, yeah, look at my code, which one is it? Yeah, this one. So this is my code for this one. And what I did was, for each angle, for each sensor, I did a complete map. So this is one here, what we're currently on the turntable. This is the angles we get. Actually, I was going the wrong way there. So what I should have done was start there at 0. Let's get rid of them. Delete that, and I should have gone that way. So we're going up, so we got 10 degrees first. So if I move that, where's my picture? Yeah, so if I move that there, I get it spot on. I got the shakes, the fingers shaking. There, so you can see it's 0.002, so we logged that. And I log in the actual raw values because this is what we're actually getting from the sensor. The angle is just the conversion. So I move around to 20. There we go. So if I get that into the point where it's 20, you can see it's 20 point. It actually sending me back 20.2, and so we logged that, and then there we go. We've done it. So what we got there? 4, 5, 6. Oh well, last time I did it was 466. This is what I found. It kept changing, and when I went from 5 volts to 3 volts, it changed again. So anyways, what I did is I did it for every sensor, and then I fitted every sensor to my thing, and it wasn't an easy job fitting the sensors back again, because I've actually sort of add some bits of well, the odd tack of glue to make sure that things don't rotate and things. And so I'll just reset things up. Yeah, so there's a test we can do. What we can do is take a side view like this. And you can see, oh, let's just minimize, let's just make that there, so we can see that I'm moving the arms. Yeah, so we can see when we move this. Maybe it's not the best view. Yeah. Well, you can see where the scanner is anyway. I'll just see if I can lock that in there. Oh, my absolute way into you. Damn. Right, yeah, so we've got that. You see, it's too big, is this project. I'm getting pissed off with it, actually. So I may sort of just put it on the shelf for a while because I'm a bit tired of it. It was proof of concept, and it just well, basically what I have to do is I need to get all these angles spot on. So yeah, what was I saying? Right, yes. So there's a test we can do. So if I bring up this, yeah, my application. What I can do is I can actually pull this down. I didn't need that one. Yeah, what I wanted to do was is put that on there and hold it in place. Right, yeah. So can you see? I'm holding this in place down here. There, so it's held in place. I mean, it all looks right. It looks like this thing, but we've got a fixed point here and a fixed point there. And if I move these two arms in between, this should remain here because I'm actually holding it here. Can you see that I'm holding it down here? So I'm going to swap arms, otherwise I'm going to get in shot. So I'm holding it there with my arm, and I'm going to move these, and you can see it's not as bad as it used to be, but can you see that it still moves slightly? Does that bottom, that last segment, it's this thing we're looking at here, this should not move. If I'm holding it down here, this should not move. And I just want to show you that the mapping counts. So at the moment you can see that it doesn't hardly move much, but it does move, and that's because I need to remap these sensors here and here and here and here. And to do that I need to take them out again and put them in here, so I can use my angle thing to map them out on the 3 volts. So yeah, we all learn by our mistakes, you know. But if I go into my program, right, what I'll have to do is I have to shut this down. So disconnect, shut that down, and then I can bring the application up. Where's my 3D scanner? There. So what we can do is, because I'm mapping all the angles, where are we? Now, oh, where are we? Maybe one of these green areas. Right, yes, here we go. So at the moment what I do is I correct through raw into interpolated and use the angle map. So I get the angle map, and then every 10 degrees I interpolate in between each 10 degrees to get a better angle. I'll demonstrate this later on. So but if what I can do is, so this is where I interpolate it. It's a short bit of code, but basically I just take that map every 10 degrees, but to calculate the angles in between the 10 degrees, they get interpollinated. So what I'm going to do is I'm going to just remove that so it doesn't actually do it. So if we comment that out, I just want to show you the need for it. So if we start up my application again, we can minimize that. Yeah, normally I'd do that on the fly. We can remount. Visual Studio will allow you to just modify odd things, but because I'm using OpenGL as well, I don't think the OpenGL library is compatible with the hot redo thing. So let's just connect, and we'll have a look on the right side. So we're looking at this again. So what I'm going to do is I'm going to actually hold. Oops, damn! Give me a heart attack now when it fell off. Right. So what I'm going to do is just going to hold that again. Let's move this across so you can see. So I'm holding it down here. So this should not move. But what I'm going to do is I'm going to move them two arms, and you should be able to see it even worse without interpollination. And it's calling me a sodding liar. In fact, that isn't too bloody bad, that's even better without the interpollination. Alright, I'm going to leave it. This is it. It's frustrating me, this. So yeah, well, anyways, this is why I think I'm giving up. I'm flogging a dead horse here. So so currently the state is, if I get that there, what I can do is set this to move things. Oh, it's on 150. Right, so we're looking at this thing here. Let's just bring it a bit further down. Yeah, it's a bit closer now. It's all green. We can have a look at the current points. Right, so this would be better if you could see what you're actually looking at. So you can see that I've now got the flat face there, and you can see the flat face there. If I just turn it slightly, you can see that we're now sort of like square on, and then we're offset again. Let's just give it a bit more of an angle. But yeah, it's looking a lot better than it used to. But the thing is, this sensor is not as I was hoping for points. What's actually happening with this is it's not the resolution is not great enough for what I want. I was hoping that these points would be actual points of measure, but they're not. Let's see, I've got this. Let's get this in front of camera. Yeah, move that. Can I move that? No. So what I was thinking, so if we've got our box, can you see what I'm drawing here? So we've got our box sort of like this. There. That looks like my box, doesn't it? Does it? Yeah. More like my box. So when it's scanning, I was thinking that these would be little points it would scan on the box, but they're not. What they are, if we enlarge this, so what we'll do is I'll just enlarge this area. So say we've got this square bit. What it's actually measuring is, well, let's go like that. It's not actually measuring points, it's actually measuring squares. So we've got like a square there, and it's covering, oh, you can't see with that hand. It's covering right like a square area, and same there. And if I do that, so it's getting an average of the whole area there. And so the points here, the points along here, they could be about 5 millimeters apart, so the resolution isn't good enough. So the point that it actually returns, which is the bit in the middle, so it's I was hoping it would be just that point there. It isn't. It's actually doing the whole area around there and averaging the whole area, and that's why we get the rounded corners. Let me just get rid of that pad. So as we're looking at it, let's bring it back there again. There. So as it scans, you can see it going round the corner. There, look. But if we turn the, well, you can see what I'm doing here with the square box. So we don't need this. I just need to make this bigger so we can see. So if I turn it around, you can see that there's like the box. Let's just put the points on and start scanning. You can see that as we scan and it goes around the corner, we're going to end up with a rounded corner because it does within the nearest 5 mil between these points. So yeah, there, can you see? It's not as accurate as I would hoped, because all these points, can you see that the it's hard to draw. If I do a thing, right, yeah. So yeah, so this is why I'm going to give up with this, because this sensor that I'm using is not the right sensor for doing this. It doesn't do it. What I'm going to do is I'm going to do a screenshot of this and try and explain what's actually happening. So just give me a moment. Yeah, here I've done a screenshot. So as I was turning, and so my scanner here is here, so let's have a look. Let's get a line and let's make it red. So here's my scanner here. This is sending out beams like this. Well, it isn't actually, it's sending one big light and we're getting reflections back, and they're coming in at different intervals because of the different thing, and it's the sensors that converts them into beam. So what the sensor is actually seeing is if a beam's coming out, well, what size is that? That's pretty big, that, isn't it? Text, objects. Oh, I've lost my thing. Where's properties? No, I don't freaking know. Right, actually. Yeah, so let's just bring that down. Yeah, so it comes out, where we're getting reflected here is we're getting an area getting an area like that reflected back, and it's taking a mean point. So what in effect it's actually doing is taking an area like that and bringing an area like that out, and then it's bringing another area out like that and bringing that back, and then it's bringing another area out like that, and so on. So what we're not actually getting dots, and that's why it's all fuzzy like this, is because we're getting an area, and as I rotate this points move around, and it makes the points dance across in this direction. So my good idea, it was sort of good, but the thing is, I'm gonna shelve it for a while. What I need to do is, what I want to do is find another sensor and sort of get a different view on it, basically. You can see the box is there, but it's not quite right. And let me just, right, so you can see the shape of that box. Also I want to show you what interpollination does. So I need to close this again because it can't do a live update. So I'll just re-enable them, or I'll just go like that, and we'll run it again. Yeah, it's a shame really. I was hoping for a different type of sensor. It needs a sensor with a big lens on the front, focusing lens to get single points, and obviously that won't fit on the end of this arm on what I've got here. So yeah, if you've been following this and been interested, it's come to a grinding halt actually. So now I've got the interpollination on there. What we can do is our points, and let's put the current points on there, and let's do another twirl. You see, you can't really tell any difference because of what it is. Let's stop doing that, and yep, you can see the box there, but now it looks more cuboidal rather than sort of what's the word, elongated. But yes, so you can sort of see that what the points are doing. They should be just if you look at these figures, it should be just dancing around 1 mil either side, but they do dance about 1 mil, so I should just end up with a fuzzy 1 mil line across. But I'm not. It's because as we turn, these are at an adjacent, more of an angle to the slope, so they actually bounce worse. I don't know if you can see it really, but can you see it as it goes around the corner? Yeah, so I don't think I'm going to get any better than this, guys, and so I'm going to shelve it until I come up with another idea. It's far too big as this for my bench as well. I want to go and find a smaller project. I haven't got no clue what project I'm going to do now, but yeah. Well, I'll tell you what, I'll continue with why I was actually changing the magnets, just so that you know, anybody who's messing around with these sensors. Yeah, I'll just reset up my camera so we've got a vertical shot. There's something else I just want to just make a point about. I'll be back in a minute. Yeah. Right, so these are my square magnets, and what I've done is I've put two there, one with the bearing on and one without the bearing, and just show you that the bearing does make a slight difference. So if we can we tell you what, let's see if I can zoom in a bit there. No, damn, wrong thing. Oh, where's me thing gone? Give me. There we go. So you can see it's got a line around it. So this is like it's the bearing's acting like a focal lens, and it's focusing the strength around it, whereas this one doesn't have it. But you can see that the middle bit here, they're both straight, and like I say, the shape, don't worry about these shapes. These little magnetic magic sheets, the work on light they've got like little crystals inside, and they rotate depending on the magnetic field, and it's the light reflecting off them that gives you these colours and lines. So although this looks like a weird shape, it may not be, because I'll just get a bright light to show you the effect. So if the light's shining from this side, you can see that we get a different shape and distortion. So what you really need is light directly above it, or ambient light, like from the sunlight shining up the room. So if I move it to the other side, you can see that it changes as well. Or if I go this way, you can see that the light this is the light reflecting off the crystals. So yeah, so when you're looking at these magnetic fields with this sheet, just make sure you've got a good even light source around it to get the effect that you're after. So you can see that the light on here is slightly offset. So anyways, yeah, so the reason for the round magnets, well, for the round magnets, the only one I can get to is the one on the turntable. So I'll have to just lift the turntable off, and so we can have a look at the one that's in the turntable. So if I turn that over, there you can see the one in the turntable. Just can I pull that a bit further this way? Yeah, there we go. So if we compare that to one with the square one, so hang on, I'm just trying to get that. Oh yeah, I can't turn that. Right, so it's going to have to be like that. Okay, so if I put the sheet on there now, I don't know if you can see, this is the square magnet. They've got really straight flux lines, you know, magnetic field lines are pretty straight, but with the round magnet, it's the green bits that we're looking at. Can you see that they're sort of curved? And what I think is happening is, with these sensors, the sensors have been designed for round magnets, so it's expecting a magnetic field like this around it, and I can show what I think was happening is what I found to be happening. Let me just get rid of that and put that back on, and then I've got something to sit the stuff on. Yeah, so here's my talking stick again. Yeah, let's go to wide and zoom out a touch. There we go, we can see the whole thing now. Yeah, so with the round magnet, I think what we had was the magnetic field was curved like this, and because we're in a round magnet, let's say the round magnet like that, the magnetic fields were coming out round like that, if you get my meaning. They're round, coming out like that, and I think that is what I think that's what the sensors are designed to pick up and calculate, is a curved magnetic field, whereas with my square magnets, so my square magnets are like this basically, and it had the two magnetic fields were straight like that. And so what this was doing was we had a magnetic field coming out round like that, but then it was going straight, and then it was going in again, and then it was coming out and going straight and then back in again. And same here, it was coming out like that but going straight here and round, and so round and straight and then round. So you can see the two different shapes of the magnetic fields. So this was calculating trigonometry, sort of going through like that, and this was calculating trigonometry going straight through like that. But what ended up happening was that the mapping points around here became oval because of the way that the trig was working on these straight lines, and it came round, whereas when I was mapping on these round circles, the angles were mapped in circular form, so we ended up with a circular type of magnetic field. I don't know if that made any sense or anything, but I found it to be true when I was actually mapping out the actual angles. As I turned this, the readings I was getting from the angles, it sort of increased or decreased, did the angles. They sort of went positive here, negative here, then positive here, and so they fluctuated, giving that sort of a result. Anyways, I've swapped them all over, and what I need to do is I need to do them all again, but with the 3 volts, because I was getting a slightly different reading. I don't know. Something changed, and it basically pissed me off, and so I've lost interest with the other stuff that are all adding up. Each thing adds up and adds up, so I think this is going to be my last video of this, until I come up with another idea of how to improve it. But it's been fun. I've learnt a lot, and I've also, I mean, that's the object of my my project, is actually to learn something, and I've learned how to draw this on my computer so that it can see, and I've learned how to do 3D animations of the actual thing. It's all been a learning curve, and that's what it's all about. So I hope you guys were just as interested in me of it so far, but I'm afraid I'm going to give it up for now until I find a nice cheap sensor that I can replace this one with, and once I do that I may come back to it. I think what I really want is maybe a spinning sensor on here that spins around and just picks up points or something, or maybe add a motor to this. Yeah, and maybe I should add a motor to this and just have it spin around with whatever is on it, and then I can just have I can just have these arms scan up and down. I mean, that's already been done, I think, so yeah, I don't know. It's been fun making it. Right, I'll just need to think of something else to make now. And plus it's too bloody big for my bench, really. It's getting in the way. I'm going to put it into spare room in one corner somewhere, and maybe come back to it another day. Okay guys, I'll catch you later.